current in a resistor lab, and basically here we want to experimentally verify Ohm's law by finding the relationship between current and voltage across a resistor. So in order to accomplish that, here we have the power supply. So this is the power supply. So the current conventionally comes from here. It goes into the slinky here, which acts like a resistor, and it passes through the slinky and then comes back to the source here. So what we will do next is that we measure the voltage across the resistor using the multimeter. So what you see here is the multimeter. We can use it to measure voltage, we can use it to measure resistance in this lab. So we will see next that how we use this multimeter to measure voltage, and also here what you see is an ammeter, and we use an ammeter to measure current. And we also see how we integrate the ammeter into the circuit. All right. Okay, next what we will see is that by setting the voltage across the resistor to these values, 0 volt, 2 volt, 4 volt, and 6 volt, we will measure the current across the resistor. I'm going to measure the voltage across the resistor by measuring the voltage that's coming out of the source. So red lead to red lead here, and black lead to black lead here. Okay? And then we will read the voltage, or we will set the voltage across the resistor to the values that I showed you earlier by turning the knob up. Right now the knob is way down, and the voltage should be 0. So that's how we measure voltage. So a voltmeter, as you can see, it's not part of the circuit. It's connected usually in parallel to the circuit. But the ammeter, which we will use to measure current, it should be integrated into the circuit. So to measure the current, the ammeter should be built as part of the circuit. That means we need to break the circuit here somewhere, and we need to insert the ammeter. So that's what we must do to measure the current. The ammeter is built as part of the circuit. So I'm going to break the circuit here and connect it here. And then this one is going to be connected here. So now the ammeter is part of the circuit, whereas the voltmeter is not part of the circuit. It's connected in parallel. Next, what I'm going to show you is I'm going to set the voltage to the values that I showed you earlier here, and at the same time I read the current from the ammeter. That we will do next. Okay? Okay, as you can see now, the power is on. So you can see the red light here, that means power is on. And I have increased the voltage approximately to 2 volt. And I'm going to show you closely the reading of the voltage in the multimeter and the reading of the current in the ammeter. Okay, so this is what you read for the voltage, which is about 2.1 volt. It's not exactly 2 volt. And the current is about 0.34 amps. That's the current that you see, 0.34 amps. 0.34 amps. All right. Okay, so this is the next reading when the voltage is about 4.3 volt. The current is about 0.6 amps. So voltage is 4.03 or 04 volt, and the current is about 0.0605. I will write down the most accurate one on the table. So this is the last reading for the voltage and the current. So when the voltage is about 6.05, the current is about 1, maybe 0.9 amps. So again, I will write the most accurate one on the table. So voltage 6.0605 volt, current is about 0.95, maybe 1 amps. So what you see here is the measurement that I took, which you saw in the previous clips. So that's the approximate value of the voltage right here, and the closest current that I was able to read from the ammeter. So current reading from the ammeter, voltage reading from the voltmeter for the slinky.